Hey guys, this is Ujjwal Kumar Sen and you are watching Ujjwal Kumar Sen English YouTube channel. So guys, in this session we'll discuss 20 more questions. So before studying, let me tell you about our test series. So we have launched our NLC test series for technical as well as for non-technical. We know there are lots of students are struggling in non-technical portion, especially technical students. That's why providing 65 plus tests in non-technical portion, including subject-wise, topic-wise as well as full length, and its price is only 299 rupees. For mechanical we're providing 10 full length tests, my dear, for only 149 rupees. Link for both the tests is in the description, you can grab it. Now let's start with question number, my dear, 61, right? A wall of 0.6 meter thickness has normal area of 1.5 meter square, is made of material thermal conductivity 0.4 watt per meter Kelvin. If the temperature on the two sides of the wall are 800 degrees centigrade and 1000 degrees centigrade, the thermal resistance of the wall is, we have to find out thermal resistance, that is what, RTH. RT is equal to what, dx by what, my dear, Ka. Dx is what, my dear, which you can see, zero point 0.6 meter, and K is 0.4 and A is 1.5. There is no problem with the unit, right? So what we're getting, 0.60 by 0.60 is equal to 1 and its unit is Kelvin per watt. Therefore option C is the correct answer for this question. Question number 62. A furnace is provided with an insulating refractory lining. The overall thermal conductivity of the material is 0.03 watt per meter Kelvin. The thickness of the lining is 100 mm. The inner and outer temperatures are 250 degrees centigrade and 50 degrees centigrade respectively. The heat loss, that is heat flux, to surroundings will be, we have to find out heat flux, that is, right? So we know that heat flux is what, small q. Let's say small q is heat flux, right? Q is equal to K, that is 0.03, and dt, that is 200, division dx, that is 100 mm. So we have to convert this into what, my dear, in meter, right? So we have to multiple with 10 to the power minus 3 for that. So let's just do calculation. 0.03 multiple 200, right, division 10 to the power minus 1. So it is, my dear, what, 60 we are getting, that should be watt per meter square. So option B is the correct answer for this question. All right, now let's move the question number 63. What we have given, consider the following statements about thermal conductivity. So there are so many things we should know about thermal conductivity, but we have given just 3. So there are, my dear, you need to remember around 8 one liner for thermal conductivity in order to answer this kind of questions, right? So we have given 3 here and few more I will discuss with you. So we have given option 1, that is correct or wrong, we have to consider, because they are asking for correct statements only, right? So we have given thermal conductivity decreases with increasing molecular weight. Of course, my dear, thermal conductivity will decrease if we increase the molecular weight, right? Next, thermal conductivity of non-metallic liquids generally decreases with increasing temperature. It is also sure, but in only if it is liquid, right? Non-metallic, not non-metallic. It is liquid. It is metallic liquid, let's say, right? So what will happen in case of metallic liquid? It will increase, not decrease, right? Thermal conductivity of gases and liquids generally smaller than of solids. Yes, in general, solid having maximum thermal conductivity as compared to liquid and gases having less thermal conductivity, right? So maximum is having maximum thermal conductivity is having by solid, and least is thermal conductivity is having by, my dear, what, that is gas, and liquid having in between these two, right? So you need to remember these things, right? Other than this, as I would like to tell you, for gases thermal conductivity will increase if temperature increase. For liquid, thermal conductivity will increase if temperature increase. For solid, if thermal conductivity metal will decrease, right? But like aluminum, it will not decrease, right? Like mercury, it will not decrease, right? So for this case, my dear, option D is the correct answer for this question. Question number 64, numerical, right? A plain wall is 20 centimeter thick with an area of 1 meter square, has a thermal conductivity of 0.5 watt per meter Kelvin. A temperature difference of 100 degrees centigrade is imposed across it. The heat flow is at. So we have to find out heat flow, right? So we know that Q is equal to K, that is what, my dear, 0.5, A, that is 1, dt is temperature difference, not dt, T1 minus T2, by dx is 20 into 10 to the power minus 2, right? So if we solve this cancel is 1 and this 10, this will again cancel, so it should be 50, 15 to 5, 250, so it is 250 watt. So option D is the correct answer for this question. Question number 65. In a furnace, the heat loss through the 150 mm thick refractory wall lining is estimated to be 50 watt per meter square. If the average thermal conductivity of the refractory material is 0.05 watt per meter Kelvin, the temperature drop across the wall will be, we have to find out temperature drop across the wall, right? So we have given these options A, B, C, D. All right. Now guys, how we can able to solve this? Let's start, right? Temperature drop means temperature difference, T1 minus T2, we have to find out. So we know that Q is equal to Q by A, we have given 50 is equal to what? K 0.05. Temperature difference, we have to find out T1 minus T2, right? That we will find out. Upon dx, that is 0.105. So let's send this to this and this to this side. So 50 multiple 0.150 division 0.05. All right, so this will cancel out. We will multiple this term with 10. All right, so this cancel out, so it is 150 degrees centigrade. Therefore option B is the correct answer for this question. Question number 66. Determine the heat transfer through a plane of length 4 meter, height 3 meter and thickness 0.2 meter. The temperatures of inner and outer surfaces are 150 degrees centigrade and 90 degrees centigrade respectively. Thermal conductivity of the wall is 0.5 watt per meter Kelvin. We have given thermal conductivity. We have to find out. Determine heat transfer through a plane. We have to find out that, right? So Q is equal to what? K, that is 0.5. A, that is what, my dear, 12. Dt is what? 60. Division dx is what? 0.2. This is the case, right? So in this case, this is cancel out and this one is 30, right? So 12 multiple 5 is what, my dear? 60. 60 multiple 30 is equal to 1800. So it is 1800 watt, right? Therefore, my dear, option A is the correct answer for this question. Question number 67. Let's understand how we can able to solve this. A plane wall is 20 centimeter thick with an area perpendicular to heat flow of 1 meter square and has a thermal conductivity of 0.5 watt per meter Kelvin. A temperature difference of 100 degrees centigrade is imposed across it. The rate of heat flow is, we have to find out rate of heat flow, that is we have to find out Q, but remember, my dear, it is asking you to find out in kilowatt. So Q is what? Q is equal to K. K is 0.5, A is 1 and its dt, that is 100 degrees centigrade. Its dt is T1 minus T2 I'm talking about, not T2 minus T1, right? So we are considering it as positive, not as negative. 20 multiple 10 to the power minus 2. This will go, so we have to multiply 10. So this and this cancel out. This one is 50. 50 multiples 250. But asking about in kilowatt, right? So it should be 0.25 kilowatt. Therefore option D is the correct answer for this question. Question number 68. An insulating material with thermal conductivity K is equal to 0.12 watt per meter Kelvin is used for a pipe carrying steam. The local coefficient of heat transfer H to the surroundings is 4 watt per meter square Kelvin. In order to provide reflective insulation, the minimum outer diameter of the pipe should be. So we have to find out minimum outer diameter of the pipe, right? So for that, what we should do, my dear, we need to find out that minimum diameter it is talking about. So first we have to find out what, my dear? First we have to find out its critical radius. So RC is equal to what, my dear? It is talking to pipe, so pipe should be what? K upon H. K is what, my dear? We have given 0.12. H is what? 4. It should be 0.03. So multiple this term with what, my dear? 1000. So what we're getting? 30 mm. Radius is 30, so diameter would be what? 60, because we have to multiple this term with 2. So it is 60 mm. So therefore B is the correct answer for this question. Question number 69. The curve for unsteady state cooling or heating of bodies is. So my dear, what curve should be there for this case? So we are, my dear, temperature and steady state should be like this, and it is, what is the curve we are talking about, my dear? It is exponential curve, right? So there is an equation behind this, and that equation also represent this one, that is what, t minus t infinity y. You can also remember this one, t1 minus t infinity. Why we where we studied about this, my dear, in case of in case of films, e to the power minus bi by tau. That is why it is talking about what, exponential curve, asymmetric to time axis. So curve is like this, right? You can remember this. Here bi is what, Biot number, that is what, HLC by k, and this is what tau, time constant, is rho vc by ha. So these things are very important. Question number 70. In lumped heat capacity system, the temperature gradient within the system is negligible. Okay, that is correct. In analysis of lumped capacity system, the thermal conductivity of the system material is considered very high irrespective of the size of the system. That is also correct and good. I mean, the correct explanation, you can say that. So option A is the correct answer. But maybe if you are new to this thing, lumped, what is lumped body? Its definition is, interior temperature remains essentially uniform at any time, right, during a heat transfer process, is called a lumped body. Just write down, I am repeating again. Interior temperature remains essentially uniform. That means the interior temperature will be same at any time. It will not vary with time. That means steady state, you can say that, at heat transfer process, is called a lumped body. So please remember that, because it will help you, my dear, to mark correct answer. Question number 71. Hassler chart are used to determine transient heat flow rate and temperature distribution when. So it is a definition, basically they're asking, let's see, infinite, no, my dear, it is not the case. Internal conduction, it is not the case, my dear. Internal conduction resistance large, no. Both conduction convection resistance are almost equal significance, yes. In this case only we can use this one, right? So option D is the correct answer for this question. Which one of the following statement is not correct? In transient flow process, what will happen in case of transient flow process? It's not correct. So let's say the rate of inflow and outflow mass are different. Yes, it is correct. State of matter inside the control volume varies with time. Yes, it is correct. There can be heat and work interaction across the control volume. It is also correct. There is no accumulation of energy inside the control. No, it is not correct. There is accumulation of energy. So therefore option D is the correct answer for this question. Question number 73. The time constant of a thermocouple is. Again, my dear, if you know the answer, you can easily mark this question. If you don't know, you cannot mark it the question correct answer, right? So let's go for the question, what it is talking about, time constant. So in this case, there is a definition. Let me just tell you what is the definition. It is defined as time required for the sensor to respond to 63.2% of its total output signal when subjected to a step change in temperature. What percentage it is talking about, my dear? 63.2%. Therefore option B is the correct answer. Question number 74. Assertion and reason. Lump capacity analysis of unsteady heat conduction assumes a constant uniform temperature throughout a solid body. The surface convection resistance is very large compared with the internal conduction resistance. So we have given A, B, C, D options, right? Now, how we can able to solve this question? Let's read. Lump capacity analysis of unsteady state condition assumes a constant uniform temperature throughout a body. Yes, that is correct, my dear. Again, next, the surface convection resistance is very large as compared to internal conduction resistance. Yes, it is also correct. Correct explanation also, you can say that. So option A is the correct answer for this question, right? Therefore option is the correct answer. I hope so. Question number 75. Dimensionless time is represented by. How we can able to represent dimensionless time? This is the question you have to solve yourself. Do your research, read from books, whatever you can do, and write the correct answer in the comment section. Let's see how many students are watching till this section. And let me tell you one more thing, my dear. All these numbers we have given are dimensionless number, right? Question number 76. For flow over a flat plate, the hydrodynamic boundary layer thickness is this much. So it can be also said that velocity boundary layer, because I have seen in few books it is talking about velocity boundary layer, the same thing. So it is denoted by what, my dear? Delta, that is hydrodynamic boundary layer. And we have given dynamic viscosity, that is what mu we have given, and specifically that is Cp, let's see, okay. And conductivity, that is K we have given. Thermal boundary layer thickness, that means delta T we have to find out. So we can use the concept of what, Prandtl number. Prandtl number is equal to what, my dear? That is that mu Cp upon K, we can say that mu Cp upon K, okay. And if you're talking about its its definition, or its how we can able to define this, that is Prandtl number. It is a dimensionless number, of course, and it is, the definition is thermal molecular diffutivity of momentum division molecular diffutivity of heat. So we can say that's like this is equal to nu upon alpha, right? Molecular diffutivity, or also we can say mu Cp upon K. Also we can say that like what, delta upon delta T power Q, right? So we usually use only these two things, right? Let's write. So mu Cp upon K, all these things we have given delta, we have to find out delta T, and its power is Q. The formula relation is there, right? And one more thing I have to share with you about Prandtl number. Prandtl number is equal to Schmidt number by Lewis number, and remember that because maybe we'll use that relation also, that relation as well in the in the coming questions maybe, right? Schmidt number by Lewis number, right? Both are all these we study in case of convection in heat and mass transfer. All right, so we have to send, we have to just do cross multiplication. Let me write delta T is equal to delta by mu Cp division K power 1 by 3. Just put the values and simplify this and get the answer. So delta is, we have to convert that into what, meter. Before solving that, we have given 1 kilo here, my dear. We have to solve this also. So it's a bit 25. Let me just do calculation and tell you the answer. You can also do calculation. 2 multiple 10 to the power 3. All right, so we're getting this much, and division K, that is 0.05, so that is 1 we're getting. So delta is what, my dear, 0.5 mm. Delta T is equal to 0.5 mm. So option B is the correct answer for this question. Again guys, very amazing question. I hope you have gone through. Question number 77. For quick response of a thermocouple to observe varying temperature of fluids, right? For quick response of a thermocouple, which one is correct according to this? So my dear, in this case what will happen, that is very important. Wire surface heat transfer coefficient must be large. That should be large, then only for a quick response is possible, right? So option D is the correct answer. Question number 78. When is transient heat transfer problem considered as a lump capacity problem, right? When it is transient heat transfer problem is the what is the basically, let me tell you what is the concept of transient basically, right? Just listen to me, it's very important. No temperature gradient within the body, right? This case is only possible if this is possible when internal resistance of the object is negligible. So if you listen to me carefully, you can mark the correct answer. That is what, option D is the correct answer for this question, because it is saying internal resistance of the object is negligible. Question number 79. In a laminar developing flow through a pipe with constant wall temperature, the magnitude of the pipe wall inner surface convective heat transfer coefficient shall be maximum at the, where shall be maximum? It is at the beginning of the flow, it will be maximum. One liner question, right? Question number 80. Consider the following statements with regard to the heat transfer. Okay, temperature variation in lump heat capacity analysis exponential with time. Yes, that is correct. And situation involving simultaneous heat flow mass transfer, right? Heat and mass transfer, the ratio convectivity transfer to convective mass transfer with Lewis number Le as Le by 1, Le 1 by 3. No, it is not possible. It can be written like this, right? So option 1 is the correct only, because it is correct. It is asking for correct only. Therefore option C is the correct answer for this question. So it's done, my dear. We have done 80 questions in HMT. So thank you very much for watching. So we have launched our NLC tests, I said earlier also. So you must grab this 65 plus tests we're providing for non-technical portion alone, including topic wise, subject wise. It's only 299 rupees. Link is in the description. For technical mechanical providing 10 full length test, it's only 149 rupees. And again guys, link in the description as well in the first comment for technical portion for your ease. Thank you very much for watching. Bye bye, see you soon, and like the video, share with friends, and of course enjoy your life. Bye bye.